Welcome to Earth Enigma. Our topic today is earthquakes, seismic waves, and tsunamis. Earthquakes, the Earth's shaky moments. Imagine you're holding a big solid chocolate bar. If you twist or bend it, you'll see it crack at some point. That's similar to what happens with earthquakes. The Earth's outer shell, called the crust, is not one big solid piece, but is made up of different pieces like a jigsaw puzzle called tectonic plates. These plates are always moving, but sometimes very slowly. An earthquake happens when two tectonic plates that are rubbing against each other suddenly slip and release a huge amount of energy. This energy travels through the earth as seismic waves, which is what causes the ground to shake. It's like when you quickly snap that chocolate bar and you feel the snap run through your hands. Seismic waves are like the Earth's way of letting off steam when it gets a bit too stressed out. Imagine you're at a concert and the speakers start blasting your favorite song. You can feel the music vibrating through your body, right? Seismic waves are kind of like those vibrations, but instead of music, they're caused by the energy released during an earthquake. There are a few different types of seismic waves, and they all have their own special ways of traveling through and around the Earth. Let's check them out. 1. Primary waves, P waves. The speedsters, P waves are the first ones to show up at the party after an earthquake happens. Why? Because they're the fastest. They can move through solids, liquids, and gases, making them quite the travelers. If you could see them, you'd notice they move in a push-pull pattern, kind of like how a slinky moves when you stretch it out and then let it go. These waves help scientists figure out where the earthquake started. 2. Secondary waves, S waves. The shake, rattle, and rollers. After P waves come the S waves, and they're a bit slower but definitely know how to make an entrance. They move up and down or side to side, kind of like shaking a rope. But here's the catch. S waves can only travel through solids, not liquids or gases. This is a big deal because it's how scientists learn that part of the Earth's core is liquid. 3. Surface waves, the big show. Last but not least are the surface waves, which arrive on the scene after P waves and S waves. These are the waves you really feel during an earthquake. They travel along the Earth's surface, causing most of the shaking, rolling, and rumbling we feel. There are two main types: love waves, which shuffle side to side, and Rayleigh waves, which roll along the ground like ocean waves. These are the ones that can cause a lot of damage to buildings and roads. How we listen to seismic waves. Scientists use special tools called seismographs to listen to seismic waves. These instruments can pick up the vibrations of seismic waves from all around the world, helping scientists learn more about earthquakes and the inner workings of our planet. Tsunamis, the big waves. Now, imagine you're in a bathtub and you suddenly kick your feet. The water reacts by forming big waves that splash everywhere. Something similar happens with tsunamis, but on a much larger scale. Tsunamis are usually caused by underwater earthquakes. When the ocean floor suddenly shifts during an earthquake, it moves the water above it, creating big waves. These waves can travel across entire oceans at the speed of a jet plane. When they reach shallow water near land, they slow down but grow in height, turning into massive walls of water that can cause a lot of damage. Waves, the ocean's rhythms. Waves in the ocean are like the ups and downs in a music beat, constantly moving and changing. Most waves are caused by wind blowing across the water's surface. The size of the wave depends on how strong the wind is, how long it's been blowing, and the distance over which it travels across the water, known as the fetch. Waves are energy moving through the water, causing the water to move in a circular motion. However, the water itself doesn't travel far. It's the energy that moves, pushing the waves toward the shore. It's a bit like when you do the wave in a stadium. You stand up and sit down, but you don't move from your spot. The wave moves around the stadium, though, bringing it all together. Understanding earthquakes, tsunamis, and waves helps us better prepare for them and protect our communities. Scientists study the earth and oceans to predict when and where these events might happen, making it safer for everyone. Remember, nature is powerful, and by learning about it, we can learn to live alongside it more safely. So next time you feel the ground shaking or see news about an earthquake, you'll know that it's all about those seismic waves traveling through the earth, delivering messages from below our feet. Thank you for going on this journey with me. Until next time, like, share, and subscribe.